Hello everyone, the topic of our project is system-on-chip implementation of an artificial neural network. In this project, we aim to design a system which can classify and count white blood cells to be used in healthcare organizations for medical diagnosis of blood disorders. First, we designed an artificial neural network which is able to classify these blood cells. To train this network, we extracted specific features from our dataset. After training and constructing our neural network in MATLAB, since neural networks are biologically inspired parallel structured algorithms, we implemented this system to a system-on-chip architecture instead of using microprocessors or DSPs. We used Intel's Altera DE1 SoC board for the implementation. This chip combines both an FPGA and an embedded dual-core ARM-based hard processor. We implemented the ANN to the FPGA part, and we ran our software on the hard processor. White blood cells defend the immune system of the human body. Therefore, their amount in blood can point to undiagnosed immune system disorders. There are 5 types of these cells, which are neutrophil, eosiophil, basophil, lymphocyte, and monocytes. There are also several devices to count blood cells like CBC machines. However, they are not fast enough and they also lack mobility and they are sensitive and more importantly, they are really expensive. So by designing a complete system of our project, we can produce a much cheaper device which can be used in the clinics and laboratories. As the result, our system is able to classify these white blood cells. We are able to control the system via Linux. The system always repeats a reset condition before every test data. As you can see from the waveform, the reset and enable conditions are investigated. The system never fails in any possibilities, and the FPGA produces its output accurately. Here you can see our resource summary, and none of them are above 10%. Also, the FPGA works at 33 MHz frequency and the processor works at 400 MHz. And here for the demonstration of our system, we hard-coded 96 samples in the software. So our software takes a user input to select the sample to be sent to the FPGA. Once the data is sent, the FPGA calculates the output type and prints the result both on the 7-segment hex display and the Linux console. To manually reset the system, simply the user can type the reset command. Thank you for your attention.